divided by square p, and this one we can relate it to b. And b in our definitions is tangent mu over q. So that is for parabolic orbit. And today I want to get this done is for elliptic orbit divided by a, and that one equal to e. So that is 4. So here, let me write up the result first, and then over there, I'm going to do very quick derivations for you. And also, universal variable divided by minus a, and that one we define as the f. So that is for parabolic. Okay, so that is the way we can relate the universal variables. And so here I'm going to give you the explanations for elliptic orbit. So here, explanations. So for elliptic orbit, we're starting from our equations for time relating to the universal that equations. And this one basically is from last time. We starting from equation 11 and equation 10. So basically here this is a simplified version by imposing initial conditions. So we start from there. Basically this is the starting point as we did for from here. Okay. So for this way I multiply this number. I simply multiply this number to the whole equations. And so in this way we can have is mu over aq times t equal to so here the s is our newly defined s functions, and the same thing here later we're going to show off c, and c is our newly defined functions here. And we can replace Rp by 1 minus e times a. Okay, so that is for elliptic orbit. So in this way, this one will be equal to what's that? That's okay. Working on that. Keep working on that one. Okay. So we plug in Rp equal to this, and we also use
OK button, the username or password, and editing text. Alt F8 to show password. Password field.
So basically here we replace the s by we introduce the s by these definitions.
Menu item.
Okay, so introducing Rp equal to this, and also introduce s with the original definitions. So that equations will become after arrangement. And here I will skip one step, and the final result will become like this. Okay. So again, we introduce this as a function of z, and here, and also replace Rp by this. And one more step, and that one can be found in our textbook. Let me skip on that one. So basically coming to here. And then by introducing our definitions of Z, so Z basically this one can be replaced by this. Okay, and here we have the definitions Z squared equal to x squared divided by a. Okay, so that is the definitions here we introduced. And so from here, basically you can see by defining x squared a equal to e. So basically that one, this equation becomes what we familiar with. Okay, so that is the Kepler's equations from the beginning for describing elliptic orbit. So that means from here we compare, we have these relations relating the universal variable to E by these quantities. Okay. So let me skip off the hyperbolic because the process will be similar. So the most important thing is this box. Okay, so once later we able to calculate the number of x, then we still have to convert into, say, finding the eccentricity. We have to use this relation. So today we have a handout there. If you kind of come in, haven't taken it, take one. Okay, so that is for this one. And so right now we have done the